Hello everyone, my name is Manshankar Reddy and I am here to discuss about the paper presentation Kafka. So, here are my teammates Satu, Surya and Revan Mutyam. So we are here to explain about the Kafka, a distributed messaging system for log processing. Okay, so Kafka. It is a messaging system, so it transfers data as a messaging system. So it is developed at LinkedIn by people by people Jay Krebs, Neha, and Narkheda and Gio Rao, who and it was founded around 2010, and in 2013, Apache acquired Kafka technologies. Before that, Kafka it is mainly designed to facilitate uh, active it is first designed to facilitate active tracking and collect application metrics and logs at LinkedIn. So there are five what we can say things that Kafka is developed to measure. It's queuing, metrics, log, database replication, and tracking data. So it was developed in language called in languages Java and Scala, and there are some of the competitors in to the Kafka. So the main competitor is RabbitMQ, but RabbitMQ it is developed by IBM. It has RabbitMQ has more what we can say features than Kafka, but IBM MQ has more features than Kafka. Kafka is best suited to large data frameworks such as Lambda and everything. So when it comes to the market share of Kafka, according to IDC, at the time of 2019, it has 1.6 billion dollars of market share, and it is estimated that by the year 2025, the market share of Kafka is going to be 5.3 billions. So as we all know, Kafka it is like it collects it, it stores it and analyze it. Apache Kafka is when it comes to like the collecting, storing and analyzing, Kafka is the only choice to reliably collection, transmission and delivery of events. Okay, so some of the main features are it is distributed system. So all the messaging systems are distributed, and it is persistent. So the messaging systems are transferred as fast as it can, and it is partitioned and offset in the partitions, like the messaging systems are divided in some categories, and it is further offset in that partition, and it also has high throughput. So the bandwidth of sending the messaging systems, it's too high in the Kafka. So Kafka is used to just move the data at very high speeds, and it is a publisher subscriber base. So like when any user is trying to send data to the database, then the publisher, the user is as a publisher and the subscriber is a database. So this is how Kafka, the history of Kafka, and what it is, how who developed it, and how it's meant to use in the beginning, and how it's going to change. So from here on, my friend Satu, he's gonna explain about it.
Hi, this is Satu. So the motivation behind developing Kafka is the real-time log processing has become very important across the companies now. So uh, various applications have come in that utilize uh, live streaming or real-time data to um, m- make their create dashboards or make some decisions based on the data that's flowing, or even monitoring like a monitoring log. Given that streaming data has become very important and the existing messaging systems have some drawbacks. For example, there are rich delivery guarantees for the existing messaging systems. Also, they focus slightly less on the throughput, so the speed is comparatively less in the other messaging systems. Also, it's not very keen or focused on the distributed systems, so the data availability and how safe the data is, that's a bit compromised. So all of these reasons could be addressed when companies were to switch to Kafka. Going forward, Kafka has these following features. So next slide. Yeah, so few of the design principles that were focused while the team at LinkedIn were developing Kafka were it has consumer iterators, which means that there's a never terminating consumer iterator that can identify where the offset, um, until what offset the messages were consumed, and whenever there is a new message, uh, they can just pull the new messages into the uh, consumers. Also, it follows a pull model, so this actually helps to avoid any overloads on the consumer, because consumers can just pull data as per their capabilities and not overwork themselves. It also it has an efficient storage system in the form of partitions and offsets, so that makes it messages even granular and accessible. It also follows page caches, so it helps avoiding double buffering of messages and also resulting in little overhead. Um, Kafka also has time-based SLA for message retention. So this means that the messages that flow to Kafka from publishers are stored for a given period of time, usually 7 days on Kafka, and are then dropped in spite of utilization or not. It also has a concept of independent consumers. So across the consumer groups, the consumers are independent, and there is no need for the coordination overhead. It also has a one-on-one relationship between partitions and consumers um, within the consumer groups, so that helps in efficient fetching or retrieval of messages from the partitions by the consumers. So the zookeeper is a service that Kafka has to provide, that actually maintains metadata of various parties that are involved in this architecture, for example, consumers, brokers, and producers. So after this, Raven could be taking over. Thanks.
Yeah, from here I'll be explaining about the evolution between the Kafka and evaluation between the Kafka and the other messaging system. In order to say that the Kafka is a very best one, it was compared to the other messaging system like Active MQ and the Rabbit MQ by taking the two terms, or by taking into the consideration between the producer and the consumer. In the very first graph, it shows about the performance of the consumer. Basically, the evaluation is done between the performance of the producer and the consumer, and by taking into the messaging system like Kafka and other messaging system. In first graph, it totally shows about the performance of the consumer. The Kafka has a highest data processing, that it has about 22,000 messages per second, so that it can easily handle data messages per second, which is almost 4 times more than the active MQ and the rapid MQ. So the Kafka has the highest message delivery rate than the active MQ and rabbit MQ, while performing the consumer rate. And when coming to the producer, the producer has a least number of bytes, like 9 bytes. Always it has to be a very least while coming to the performance of the producer, so that Kafka has a least number of 9 bits. And when coming to ActiveMQ or RabbitMQ, there has almost 144 bytes, which overhead in ActiveMQ. And when coming to the pretty at the time of the Kafka invention, they have lack of these three elements, like replication, acknowledgement, and the processing capabilities. While considering into the replication, it was divided into the many parts, so that each part has a different brokers. Like if we encounter some problem with the data querying or the message processing, it should be handled by the replication. Like the particular kind of problems will goes into the some section, and the different kind of problems goes to the other section. So if the solution is not found in the one section, it will be chosen, or it will be goes to the another section to find its solution. So that anywhere you go, you need to find a solution for the data error. Like there should be a more availability of solution, and it has to be a durability. All this comes under the replication. And while coming to the acknowledgement, it also has a lag in acknowledgement. Like if you consider producer and the consumer, like if consumer has some kind of problem, it has to send a message to the producer that he or she is facing some kind of issue with the data, or with the data processor, so that the consumer will be sending a message to the producer, and the producer will has some solution for this kind of, or for such kind of problem. So he'll be sending back solution to the consumer with an acknowledgement that it makes that guarantee message delivered to consumer through acknowledgement. If for suppose if the producer has a new solution for that, he will be connecting to another connector, so that he or she has the solution for the problem, so that it will be counting into two or three acknowledgements. So anyhow, the solution has to be there for a particular kind of problem. And while coming to the process capabilities, it has to be handled uh, a different kind of, or it has to be facilitate more quality of data streaming processing capabilities. Like it only not it does not count, or it should not solve a one particular kind of problem. It also has to solve, or it has to give some more performance in handling the errors. And from here, my friends, I will conclude the Kafka.
I think there is a internet issue with him. I'll just I'll call him and I'll try.
Yeah, sorry. Uh, well, to sum it up, what my friends have discussed so far, Kafka is the system for processing huge volume of log data streams. We can see Kafka employs a pool-based consumption model. that allows applications to consume data at its own rate and rewind consumption whenever we need it. If we focus here log processing applications, am I audible?
Yes.
చెప్తున్నా వినపట్లేదు.
Yeah.
Oh,
Yeah, yeah.
sorry. We can, if we focus on the log processing, Kafka receives much higher throughput compared to the conventional messaging systems. Mm, the like we've been using the Kafka at LinkedIn for both online applications and offline applications. If we can see currently a rough figure of about 33,000 companies have been using the Apache Kafka in their tech stacks. Some of the popular companies includes like Twilio, Trustwave, Edward Jones, Redundancy, and some more. Uh, Going further, we have number of directions to pursue in future. Um, like for first plan, we can add the built-in reapplication of messages across multiple brokers to allow some trade-off between the um, allow durability and data availability guarantees even in the worst case of unrecoverable mission failures. And we will be supporting both synchronous and asynchronous replication models to allow some trade-off between the producer latency and strengths. Um, by choosing the right level of redundancy, basing on the requirement of durability and availability, throughput, and for the second, we can add some stream processing capability for Kafka for retrieving the messages, real-time applications performing similar operations such as window-based counting and joining each message with records in same in another stream. Uh, it provides the foundation for processing distributed streams like consumer missions. Mm, like the kind of applications which are beneficial are helpful stream utilities, windowing functions, and join techniques. Um, while in our assessment of the paper, we found some questions which we should keep in mind, like um, given the performance boost using Kafka and the possible stream processing additions, can this be replaced to a database such as a Hive and not just a message streaming queue in the future? And also, can the real-time IoT devices be relying on Kafka as there is possible of data loss due to the unavailability of acknowledgement in the architecture, which could be a huge risk in some use cases? We figured out these questions can be raised. Thank you.
Okay, to submit up the presentation. So this is all the team we uh, prepare for the paper of Kafka. So thank you.
Thank you, guys.